Hello, this is Group 5 of MS1011. In this presentation, we'll show how material science drives smarter food packaging, balancing safety, performance, and sustainability. Packaging is a barrier system. It blocks moisture, oxygen, light, and microbes, preserving taste, texture, and nutrients, as well as extending shelf life. Good design also reduces spoilage and waste, so material choice affects both food safety and the environment. We typically see plastics like polyethylene or polypropylene for lightweight and strong moisture barriers, paper cardboard for printability and renewability, though in its coatings against water and grease. Metals such as aluminium and tin plate with excellent oxygen or light barriers and heat resistance protected by food-safe lacquers. Glass, which is chemically inert and endlessly recyclable but heavy and fragile. And lastly, bio-based options such as polylactic acid or cellulose, which are compostable but can be heat or water limited. The best choice depends on the food type, processing method, and sustainability goals. Now, we'll dive deeper into each material's properties, use cases, and trade-offs.
So now we'll talk about plastic for food packaging. The type of plastic is commonly used is PET plastic, HDPE, LDPE, and PP plastics. For food packaging, the key mechanical material of plastic are lightweight, which helps reduce production costs, carbon footprint, and transport effort. Stiffness, to provide strength for containers, flexibility, so it can conform to the product shape, and durability, making it less likely to break compared to glass. Now let's look at the advantages and the disadvantages of using plastic for food packaging. Firstly, the advantages. Most plastic are excellent barrier against moisture and water vapor, especially materials like polyethylene and polypropylene. They are also non-reactive with acid and salt in food. They are lightweight, and some types are easily recycled. Most importantly, they help to extend the shelf life of the packaged food. However, there are also some disadvantages. Multi-layered plastic, which are used for stronger barriers, are difficult to recycle because of their mixed material. Some plastic can latch harmful chemical into food under high heat. And finally, most plastic are non-biodegradable, meaning they can last for hundreds of years in landfill and ocean.
Next, let's move on to biopolymers, where we'll be talking about cellulose and polylactic acid packaging. Cellulose is an organic carbohydrate polymer that is made from cell wall algae, which forms an environmentally friendly alternative to plastic and styrofoam products. Some properties of cellulose packaging include being biodegradable, renewable, lightweight, strong and durable, low cost, and low carbon footprint. Some disadvantages of cellulose packaging include being not waterproof, not as durable as compared to conventional plastics, not cold-resistant, and not suitable for food preservation on its own. It has to be in conjunction with different materials for it to create a barrier against external factors. Next, moving on to polylactic acid packaging. It's a film coating made from cornstarch, sugarcane, sugar beet, and cassava to form a biodegradable bioplastic that is used to make containers, film, and disposable cutleries. Some advantages of PLA is that it is transparent, it helps to preserve fruits and vegetables, it is recyclable. However, it is not suitable for hot food and reheating. For more heat-resistant properties, crystallized PLA can be used instead.
Moving on to metals, aluminum, steel, and stainless steel are widely used as food packaging materials. Aluminum is what you see in foil wraps and canned drinks. It's light and easy to shape. Steel are used for canned foods because they're strong and keep food safe from air and bacteria. And stainless steel in reusable lunchboxes are tough, shiny, and rust resistant. Metals are amazing because of their properties. They are malleable, meaning we can press them into thin sheets for all kinds of packaging shapes. They have barrier properties, so no gas or moisture can get through. That keeps our food fresh longer. They are also strong enough to protect food during transport, and their thermal resistance helps them handle high heat during sterilization and cooking processes. But of course, metals aren't perfect. They are energy intensive to produce, which means more greenhouse gases. They are non-biodegradable, so if we don't recycle properly, they'll stay in landfill for years. They're also heavy, which increases shipping costs, and if uncoated, they can rust, especially with acidic foods. So while metals are durable and protective, we need to use and recycle them responsibly.
Glass is a food packaging material that is commonly used. It's a ceramic mostly made of silica with sodium oxide and calcium oxides, plus small amounts of magnesium, aluminium, and potassium oxides. Its atoms sit in a highly disordered amorphous network, and it provides us with the chemical properties being chemically inert so that it won't react with food, and the food, flavor, freshness, and nutrition are preserved. On the other hand, it's also thermally stable and it's safe in microwaves and oven, and it's able to withstand high temperature. And the third is that it's sustainable and it's 100% recyclable without losing quality or purity. However, the disadvantages includes the glass being fragile and making it requires very high temperature, so the energy consumption and production costs are higher than plastic.
To conclude, good packaging protects food, while great packaging protects the planet, and material science bridges both by building a future of safety, innovation, and sustainability. These are our citations, and with that, we have come to the end of the presentation. Thank you for watching.